Hello friends, so today we discuss the virtual memory and that is comes under operating system chapter, means operating system subject. In operating system subject a chapter is coming, that is virtual memory. And I think in MCA syllabus, in Odisha in MCA syllabus, the mainly virtual memory is comes under unit 3. So not only in Odisha but also in all over India or in universe. So so let's discuss the virtual, what is virtual memory. And the subheading of virtual memory are demand phasing, page replacement, allocation of frames, thrashing, memory mapped files. So here I am just putting this syllabus in ChatGPT, and ChatGPT provide me some notes on the basis of this above syllabus, means what is virtual memory and some key idea of virtual memory, and like after that demand phasing, how it works, its advantages, disadvantages. Then second is page replacement and some common page replacement algorithm like FIFO, fast in fast out, LRU, latest recently used, optimal, LFU, least frequently used. Sorry, LRU means least recently used, and LFU least frequently used. And third is allocation of frames, the definition, types. Types में types are equal allocation, proportional allocation, priority allocation, thrashing in comes under thrashing, definition, cause, solution, these are comes under thrashing. And after that in point 5 memory mapped files are also given. Here is also given the definition of memory map files, how it works, advantages, summary. So just reading this syllabus theory. After that what I will understand, I will read. So what I will understand, that I will tell you. that I will mm, that I will that I will that I will that that I that I that I that I clarify to you. So virtual memory. Virtual memory is a memory management technique that allows the execution of processes and that may not be completely in the main memory, means in RAM, and it gives an illusion to the user that there is a large continuous block of memory available, even if the physical RAM is smaller. Some key idea: parts of program, and it is these are loaded into memory only when they are needed, and the rest stay on the disk. Demand phasing. Definition: demand phasing is a technique where a page is brought into memory only when it is required during program execution. And how it works: the process start execution if page needed by the CPU and which is not in memory. As a page fault occurs, the operating system loads the required page from the disk into RAM. The process resumes execution. Here advantages of demand paging: save memory, reduce loading time, allow uh, larger programs to run. Some disadvantages of demand paging: page faults cause delays, more disk input output operation. So now page replacement. When a new page needs to be loaded and no free frame is available, the operating system must replace one of the existing pages. And here some common page replacement algorithm: FIFO, fast in fast out; LRU, least recently used; optimal; LFU, least frequently used. So first discuss the FIFO. FIFO means fast uh, in fast out. The oldest page in memory is replaced fast. LRU, least recently used. The page that has not been used for the longest time is replaced. Optimal, the page that will not be used for the longest time in the future, which is replaced. Used for comparison, not practical. LFU, least frequently used. The page with the fewest accessories is replaced. Allocation of frames. Definition: it determines how many frames, blocks of physical memory each process gets. Allocation of frames. It determines how many frames each process gets. Types: equal allocation. Each process gets an equal number of frames. Proportional allocation. Frames are allocated according to the size of the process. Priority allocation. Higher priority process get more frames. So now comes to thrashing. Thrashing occurs when the system spend more time swapping pages in and out of memory than executing actual processes. Cause what is the definition of thrashing? Thrashing occurs when the system spends more time swapping pages in and out of the memory than executing actual processes. Cause too many processes competing for limited memory, leading to frequent page fault. Solution: reduce the degree of multiprogramming, run fewer processes. Use a working set model to keep actively used pages in memory. So now comes to the 5.5, that is memory mapped files. So definition of memory mapped files: a memory mapped file allows a file to be accessed as if it were part of the main memory. How it works: the operating system maps the contents of a file directly into the process's address space. The program can read or write the file as if it were reading writing memory. Advantages: of memory mapped file: faster file input output, useful for inter process communication (IPC). So here is summary table. Concept: virtual memory. Description: illusion of large memory space. Example: run large apps on small RAM. Demand paging: load pages only when needed. Page fault handling. Example: concept of page replacement. Description: replace old page when memory is full. Example: FIFO, LRU, and others are optimal, LFU, least frequently used, LFU, least frequently used, LRU, least recently used, FIFO, fast in fast out, optimal. Page replacement: replace old page when memory full. FIFO, LRU. Frame allocation: distribute frames among processes, distributes frames among processes. Frame allocation. Example, equal proportional. Thrashing, too many page faults. Example, reduce processes. Memory mapped files. File treated as memory. File treated as memory. Memory mapped files. Example, fast file access. Would you like me to create diagram notes PDF? No, I need note for MCA and GATE standard. GATE standard. Perfect. Here a well structured exam standard note for MCA and GATE on virtual memory and related topics. It includes crisp definition, key points and explanation suitable for both university theory and competitive exams. Now discuss some notes on virtual memory and its related topic, which are mainly MCA and GATE standard exam note. So virtual memory definition. Virtual memory is a memory management technique that provides an illusion of a very large main memory to the user by using both RAM and secondary storage disk. So here I am just telling you to all the students or all the viewers that nowadays the memories present in all types of smartphone means nowadays all types of memory are comes with this virtual memory. You can extend your RAM, and that's the extendable memory portion is known as virtual memory. So it allows execution of processes that may not be fully loaded in main memory, improving multiprogramming and system efficiency. Need for virtual memory. Programs are often larger than physical memory. Efficient utilization of RAM, faster program execution through multitasking, isolation between processes, address translation. Logical addresses means virtual addresses generated by CPU. Physical address, actual location in memory. Mapping done by memory management unit MMU using page tables. Paging and page tables. Paging divides memory into fixed size block. Paging divides memory into fixed size blocks. Pages in virtual memory, frames in physical memory. Page table maps each page to a frame. If the required page is not in memory, page fault occurs. Paging and page tables. Paging divides memory into fixed size blocks, pages, frames. These are similar and equals also. Pages in virtual memory, frames in physical memory. Demand paging definition. A lazy loading technique where a page is brought into main memory only when needed. That's known as demand phasing. Step on page fault. Operating system checks if the reference is valid, finds a free frame, reads the page from disk into the free frame, updates the page table, restart the process from where the fault occurred. Advantages of demand paging: reduce memory waste, decreases initial load time, obviously, because in case of paging of paging in starting time, then from the time of starting uh, memory are used. Then that's maybe like waste of memory. So demand paging, uh, in through this process, memory waste will be reduces. And if the memory waste will be reduces, that decreases the initial load time, because if the small amount of memory are initialized from starting time, then that load time of that memory will be also require a small amount of time, or need small time duration to loading the page. So decreases of initial load time, and reduces memory waste. These are the important two advantages of demand paging. And after we after we read the advantages, some disadvantages are also seen in this heading, like high page fault latency, and requires efficient replacement algorithm. In some disadvantages of demand paging: high page fault latency, and second one is requires efficient replacement algorithm. So next point is page replacement algorithm. When all frames are occupied added a sorry when all frames are occupied and a new page must be loaded, the operating system replaces one existing page, so through which that process page replacement is occurred. And some algorithm are used by today's uh, tech. That's algorithm are FIFO, optimal, LRU, LFU. FIFO, fast in fast out; LRU, least recently used; LFU, least frequently used. So here some description, pros and cons. So FIFO, fast in fast out; oldest page replaced fast. Pros: simple. Cons: suffers from Beladis anomaly. Optimal: replace page not used for longest time in future. Pros: minimum fault. Cons: not practical, future knowledge needed. LRU, least recently used. Description: replace page least recently used. Pros: good approximation to optimal. Cons: requires hardware support. LFU, least frequently used. Replace least used page. Logical. Pros: logical. Cons: can be slow or costly. Frame allocation. Definition: frame allocation determines how many frames each process receives in memory. Frame allocation determines how many frames each process receives in memory, and some schemes are like equal allocation, proportional allocation. Equal allocation, each process gets the same number of frames. Proportional allocation, based on process size. Frame size equals to size I divided by total size into total frame. Size by total size into total frame equals to frame. Based on process priority, high priority process gets more frames. Based on process priority, high priority processes gets more frames. Global versus local allocation. Global process can replace pages of any other processes. Local process can replace only its own page. Thrashing definition: a condition in which the CPU spends most of its time swapping pages in and out of memory rather than executing in instruction. Thrashing: a condition in which the CPU spends most of its time swapping pages in, pages out, pages in, pages out, swapping pages in and pages out of memory rather than executing instruction. Causes: too many processes competing for new frame. High degree of multiprogramming. Effects: sharp decline in CPU utilization, increased input output operation. Solution: reduce degree of multiprogramming, use working set model or page fault frequency control. These are the solution of thrashing. After that, working set model: each process has a working set of pages actively used in recent past based on time window. Keep all pages of the working set in memory to avoid thrashing. Keep all pages of working set in memory to avoid thrashing. So next, memory mapped files definition: a technique where a file is mapped directly into the address space of a process. If we discuss the after discussion of definition of memory mapped files, so here is some characteristics of memory mapped files. So first one is file input output done via memory access instead of read write calls. Okay, so next point is next point means next characteristics of memory mapped files is provides faster file access and simplifies data sharing between processes. Okay, so now some advantages of memory mapped file. Efficient file access means no separate input output buffer, and second advantages is useful for inter-process communication IPC, and so it supports shared memory. Important terms summary: virtual memory, logical memory larger than physical memory. Page fault: requested page not found in RAM, then page fault is solved. Page fault is seen. Thrashing: excessive paging leading to performance drop. Working set of pages actively used by a process. Thrashing: excessive paging leading to performance drop. MMU: MMU, 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 MMU. MMU, that is MMU, Memory Management Unit. Hardware that maps virtual to physical addresses. Swap space, disk space used for virtual memory. Key formula: effective access time EAT 1 minus P into MA plus P into page fault time. P here P is page fault time and MA is memory access time and EAT effective access time. EAT effective access time and P is refers to page fault rate and MA memory access time. So EAT formula is 1 minus P into into memory access time plus page fault rate into P into page fault rate time. So page fault rate, fraction of memory accesses that result in page fault. Exam tips: GATE plus MCA. Focus on LRU, FIFO, optimal algorithms with example. Understand Beladi's anomaly may appear in GATE exam. Yes. Be able to calculate effective access time. EAT. Know causes and prevention of thrashing. Working set and page fault frequency control. Working set and page fault frequency control are theoretical but important for short note question. So thank you for watching this video.